another slide which is giving little more little in depth about the previous slide. Okay, you can see it is a full duplex architecture. Okay, so antenna will be single. It will switch between the transmitter and receiver based on the your mechanism. Like our mobile system, you can transmit and do receive also both things. That is a full duplex operation. So LNA is there, mixer is there, IF A to D converter. Then you take the digital data to the processor or FPGA, general purpose processor or DSP processor. Do whatever you want, like digital demodulation or digital filtering. Okay, decimation we call. Okay, those all aspects you can do in the digital in and similarly to the transmitter also. Okay. So what are the sections in the baseband will be there? Okay, transmitter baseband. So now we understood there is a two paths. One is the receiver path and transmitter path. So receiver path we are doing the digitization and getting the data to the FPGA and do the baseband processing. And transmitter baseband, what are the blocks involved? Okay, that I am giving in the next section. So these are the baseband unit in the transmitter section. Okay. So basically, what any data, what I am talking voice signal, you digitize whatever A to D converter resolution and make a frame. Okay, it is a one kind of frame. It is just protocol where you make the one frame and do the coding. Coding means encryption algorithms, like security point of view, and also some codings which can give the better error correction. Okay, FEC we call forward error correction. All those things you can do in a coding. Then do the digital demodulation and digital front end. You give it to the digital. Okay. Then from there you will give it to the DAM, digital to analog. Then give it to the power amplifier and transfer. So these are the technique which basically used in a baseband processing unit in a transmitter. And similarly for the receiver. How? So that last ending part is a digital front end. Here the first component. Then you do when the frame is transmitting to the channel. Channel is our free space. Okay. There is always the delay. Okay. So free space can be defined as some RC component. Okay. That gives some delay in your data. So but you need to make the synchronization. Okay. Otherwise you will lose sometimes you will lose the information. So you make sure the synchronization needs to be taken care. Then you do the demodulation and decoding. There you are doing the coding and the decoding you do and give it to the final LNA and receiver side. So these are how this HDR platform evaluation is started. So basically this evaluation, first evaluation is started like this. So bring the digital part as close to the antenna as possible. Okay, that means you right after the LNA, if you do the digitization, you capture entire band of the signal and do rest of the baseband processing in a digital fashion. So that is what defines the HDR. So now people are aiming this architecture. Okay, they are trying to implement it with this high-speed ADCs. Okay, for that actually I want to capture wide band signal. Let's say my bandwidth is a 10 mega. What is the sampling required for the ADC? You know sampling theorem, correct? So what is the minimum sampling frequency required to satisfy the Nyquist criteria? 2 times, correct? So 10 mega is my bandwidth. So 20 mega is sufficient to reconstruct my signal. Okay, that is the minimum sampling for the A to D. Let's say I take a very wide band signal right after the antenna. Antenna is a wide band antenna. So let's say I take 10 giga. What is the bandwidth required? 20 giga. 20 giga sampling means 1 by 20. How much time you will take? You need to sample and hold that value. So it is very challenging. So how people are adapting that ADC architecture is a very wide kind of literature will be available. How they implement the wide band A to D converter. Okay, so those things will be slowly evaluated.